Hello, welcome to the 15th lecture in ML series. In this lecture, we will be discussing about basics of artificial neural networks. Artificial neural networks are loosely inspired from the structure and function of a human brain. When you look at the structure of a human brain, it approximately contains 100 billions of neurons, and each neuron is connected to about 10,000 other neurons. That means it's massively interconnected. And when you look at the function of a human brain, and the humans are very good at recognition tasks. Like even on a crowded place, in a fraction of seconds, you can recognize your mother's face. Unlike a computer, what they observed is, unlike a computer that process instruction one after another, the brain process information in parallel. Many neurons fire at the same time, and the knowledge isn't stored at one place. It's spread across those connections. That's called a distributed representation. So there are four key ideas that they have taken from the structure and function of a human brain. One is you need a simple processing unit, that is neuron, and those neurons must be massively interconnected, and the information must be distributed, and the processing should be done in parallel. These are the four key ideas that they had taken from the biological neural network, and they had constructed an artificial neural network. So this artificial neural network contains simple, highly interconnected processing units. We call it as a neurons or nodes, and these neurons or nodes are organized in layers so that the information can be processed in parallel, and the information flows from the input layer through one or more hidden layers to an output layer. Like for a brain, information comes from the senses or a sensory organs like eyes and ears and nose. So here also you will get an information from the from some external source through input layer, information processed in one or more hidden layers, and you will get an output through an output layer. So, and each connection between neurons has some associated weight. This is mimicking whatever the concept of biological synapses, where the actual information is stored. So how a artificial neural network learns something? It is by having some values to these weights based on the training data. So now why the artificial neural networks are powerful? As we have seen, the linear and the logistic regression models, those are powerful for linear relationship, but they fail when you have a non-linear relationship and a complex relationship. So artificial neural networks can be used to model complex and non-linear relationships also. And another important feature of these artificial neural networks is it can take directly a raw data. You don't need any feature engineering to identify some features like an image data or a text data. It can directly take the data, and then it can discover the relevant features and then do some tasks. So this is one of the reasons why it is popular, like in ChatGPT, like kind of applications. And we had seen one of the ideas that they had borrowed from the biological neuron, having the parallel processing capability. As the neurons are are kept in these layers which are interconnected, which allows the efficient parallel computation. And and in the experiments, they what they found is, and it is robust to the noise. Even if you have an incomplete or a noisy data, the neural networks works well. And one of the goals of the machine learning systems was to know how well it generalizes, how well it works on unseen data. And surprisingly, that neural networks is capable of generalizing well. So the brief history of the artificial neural networks. So initially in 1943, McLeish and Pitts proposed a simple model of a neuron which does not have any capability of learning, but a simple model of a neuron. In 1950s and 60s, Frank Rosenbelt uh, extended this simple model of a neuron to have a capability of learning a functions. That is where they proposed a perceptron algorithm. And initially they claimed that it can be used to solve any problem, but later uh, scientists came up with a problem called an XR problem, where they said that this perceptron can only use it for linearly separable patterns. If you have a non-linearly separable patterns, this perceptron algorithm is not going to work. This led to a disappointment in the AI research. Later in 1980s, the rediscovery of the backpropagation algorithm and having a multi-layer network which can be used to solve non-linearly separable patterns also reignited the interest in the AI research. And the research continued, but due to the inherent complexity of this backpropagation algorithm and needing many layers of the network for solving problems, at that time, due to the computational limits as well as the lack of data, it has not continued, and at the same time support vector machines gained popularity. So from 2006 onwards, due to this advancement in many core and multi-core systems, where a graphic processing units can be used for the general purpose computing, led to new interest, and having a large data set due to the thanks to the digitization and the new architectures and the new training techniques led to many breakthroughs in image and speech and natural processing tasks. This course, first we'll start with the perceptron model. So what is perceptron? Perceptron is a single neuron which takes n inputs and classifies it as either positive or negative. That means it can be used for binary classification tasks. So how it works is a single neuron which takes n inputs from external source, and each input has some associated weight, and these weighted inputs are summed up and a bias is added. Bias can be either represented by either W naught or B, and this will be given as input to some activation function, and the result that you are going to get in this example, we are using activation function as a step function, so that whenever the summation is greater than 0, it classifies as a positive class, otherwise it classifies as a negative class. This is how a single neuron can be used for a binary classification. So let us try to understand these units in detail. So you have an input layer, or from an external source we will get input where the input is x1, x2, so on, xn, and each input is connected to a neuron with some weight that is represented with Wi, and Wi is actually representing the strength or importance of that each input, and you have a bias, additional input bias, we acts as a threshold in deciding when to take a positive class and when to take a negative class. So now we have this weighted sum, that is Z, Wi sigma I is equal to 1 to n Wi xi plus B. B can also be represented as W naught, and you can take x naught as 1, then you can also represent it as this as I is equal to 0 to n Wi xi. Now you have an activation function. This the output of the activation function is the output of the neuron. For a basic perceptron, this activation function is the step function or a heavier function. So whenever the threshold is whenever your weighted sum is greater than or equal to 0, it classifies it as a positive class. Whenever it is less than 0, it classifies it as negative class. Okay, so now let us try to understand how this can be used for classifying. So let us understand with a simple example. You consider a Boolean function AND. two input and Boolean function. So as we know that two input Boolean function, let us consider those inputs are x1 and x2 and the output is y. So as we know from the functionality of the AND gate, when both inputs are 1, then only it gives 1, otherwise it gives 0. So there are 4 data points like 0, 0, 0, 1, 1, 0, 1, 1, 1. At 1, 1, it gives 1, and all the remaining data points it gives 0. We can also consider this as a classification problem where it is expected to give a negative class at 3 data points and a positive class at 1 data point. Now if you draw it with x1 and x2 and representing this 0 1 0 1 0 0 1 0 data points with a dot and 1 1 data point with a positive symbol. Now you can easily see that you can draw a line to separate this. You can draw a line to separate these data points. All the points that are above that line belongs to one class and all the points below that line belongs to another class. So that means we can choose W values, W1, W2, B values such that we can get this line. So that's what we had shown in this example. If I choose W1 as 0.5 and W2 as 0.5 and B as minus 0.75, and if you substitute x1 equal to 1 and x2 equal to 1, we are going to get this weighted sum, that is 0.5 into 1, 0.5 into 1 minus 0.75. We are going to get a value which is greater than or equal to 0. Then as we had considered a step activation function, you are going to get the output as 1. For all the remaining other inputs, either 0 1 or 1 0 or 0 0, you are going to get less than 0. So you will get an output 0. This is how the perceptron having these weights W1, W2 and B, we can use it for classifying AND. Similarly, we can have another example for OR where we can choose an appropriate W1 and W2 and values. Similarly, it can also have some weight values. It can also be used for the NOT gate. Now, so we had directly shown the W1, W2, B values, but as we said that this perceptron is having a capability of learning. So what is the learning algorithm that it uses? So it actually uses a learning algorithm. So initially it starts with a random weights, and then the weights are adjusted based on the error. So this t minus y cap, t is the expected value and y cap is the value that is produced by the neuron, and the weights are adjusted by using this formula, that is eta is the learning rate, eta into this error into xi, the corresponding xi. So process of adjusting weights are repeated until you get a w values which classify all the data points correctly. So as we have a perceptron convergence theorem which says that if the training data are linearly separable and you have a sufficiently small values of eta, and the perceptron is going to converge. Thank you.